Greetings, today at Teardown, and I've got something special. There it is, here in this box. Now, what this is a mobile phone. But not your usual mobile phone. It's not a Sony or Samsung. It's a CLEARTONE. CLEARTONE model number CTN9000. A relic of the past, something that used to be carried around by businessmen and people with loads of money, because those things were not cheap. They actually cost, you could buy a car for the price of one of those. So let me show you how mobile phones were packaged when this was released. So the whole thing is in a cardboard sleeve like so, and as you can see, it's a CLEARTONE cellular portable model CTN9000 and the serial number, complete with desk charger CH920 and spare battery. Styrofoam. We've got the brick itself. It's hello. Well, it's not small and not light, to say the least. We've got the charger. Well, it doesn't sound very healthy. And we have a spare battery, 1100 milliamp hours, none of the lithium ion or lithium polymer stuff. Nickel cadmium NICD battery pack. So there's 3 NICD battery cells, 7.2 nominal, 7.2 volt nominal voltage on here. May explode if disposed of in fire. Okay. Usual stuff, I guess. Flaming batteries are not a modern invention. The charger's quite heavy. I've got the charger's taking 14 volts, 300 milliamps. So I'm not sure what's inside. I suspect there is not much in there, and there is just like a metal plate weighing it down. If it was too light, you would pick up the phone with the charger, and that wasn't desired. Here is the charger, and here is a battery. You could charge the battery in a separate slot, and you could charge the phone through the proprietary connector at the bottom. If you were out and about, you couldn't ask your friend, hey, have you got a iPhone or have you got a micro USB charger? This wouldn't work. You had to either lug this bit of plastic around with you, or you just were out of juice. That's why you had the spare battery, so possibly with a little bit of luck this would take you throughout the day. At the bottom we've got just regular Phillips screws, so let's get those undone. Let's see. Oh wow, there is actually electronics in here. It's all connected by wires to the front panel, or to the top panel, I guess. And there's 2 LEDs in here and the proprietary connector, so we can take those off too. I'm wondering what sort of plastic is it. I don't know, it just feels heavier than ABS, but it looks like ABS. Oh, that's what was rattling, so that was here. It was a screw holding. There is actually a weight in here underneath. It's a big metal lug. I'm surprised that they've actually had to build the electronics into the base of the charger. So what was in the plug pack? The stuff that you plug into the wall. Socket should slide out. Power socket, there we go. We've got the electronics out. Piece of thin plastic, presumably to electrically isolate this, just in case, because a PCB was just sitting on top of it. And we've got 2 steel plates, which weigh a ton actually. Well, maybe not literally, but yeah, they're reasonably heavy. And this is what was keeping the base of the charger from floating around. And we've got a date code, October 1989, BA10393. Presumably that's some controlling for nickel cadmium battery charging. There is a D15638 transistor on the heatsink with a sill pad, a few power resistors, a couple of small transistors, couple of bigger transistors, battery contacts for the spare battery charging, and a bunch of resistors and 1 diode. And that's all there is to it. Look at the size of the heatsink, it's absolutely huge. It's aluminium, nice recessed screw over here holding it in place, but yeah, the heatsink is absolutely massive. And look at the PCB. So I'll bring it up close. It's the paper resin type PCB, and with age it's gone all yucky and stuff, resin leaking out of it. Brings a tear to the eye. Over to the phone itself. There you go. That's something modern phones do not have anymore. I wonder why. An antenna, and that should unscrew. There we go. The moment you push it all the way out, the ring around here is kind of spring loaded, so it grips onto the contact here very firmly, which is nice. That's for good contact. Good contact means good reception. Now, before anyone starts shouting, why don't I try to power it up and see what happens? Well, I did, and it's giving no signs of life. I've given it 7.2 volts on the input of the battery, and it's not having anything. I've pressed and held every single button and combination possible. Yeah, not working. Let's take this one out first, and that reveals not much really. This is the positive. So positive just goes straight through the spring onto the other side, and negative, there is a track on the back that goes to the to where the screw is in the middle, and that screws into the phone body. But having only those two screws on the back, I'm worried, how will this come apart? It can't be that easy, just two screws? No way. Oh, wow, this is amazing. So if you've ever seen a teardown of a mobile phone these days, or something modern, the amount of messing about required in order to get to the insides of it is absolutely ridiculous. Okay, we've got a case, we've got here a screw is holding, that's just a clip to release the battery, so not much there. And here is the phone itself. So yeah, there's 4 screws on each side, so let's give those a go. We've got some decasing. So this PCB stays in the phone, made in Japan, most definitely. Mainly the keypad, the LCD driver, the earpiece and the microphone and all that sort of stuff, and the backlight for the keypad. I can see some LEDs over here, and interestingly those are LEDs that shine through the PCB, so there must be a hole underneath, so they're reverse mounted. And here we've got all the voodoo stuff, trimmer pots in a mobile phone, and 1, 2, 3, 4, 5, 6, 7, 8. So 8 trimmer ports. If your phone had bad reception, possibly it wasn't tuned right, so you could take it apart and turn it to the right frequency, and maybe that would have improved your reception. And of course everything is extremely heavy shielded. Let's keep this to the side and take this apart, because the other module, that's RF stuff, this is what's going to be the most interesting. I want to leave it to last. So the PCB, I've taken the 4 screws out, and the PCB is held with little tabs over here. Okay, that came out. And we've got dual microphones. Okay, that's interesting. And a massive earpiece. In the spirit of taking it to complete atoms, let's take this out as well. Again, metal steel plate holding the earpiece. You don't get that these days. And the earpiece, and it's got nice rubber shockproof mount. Why do we have 2 microphones in here? I do not understand. Well, this is more like a speaker, to be honest. It's like an earphone, so it could be a dynamic microphone, this. And then we've got an electret microphone on this side. Here we've got NEC Japan D7225G chip, which most definitely is driving the LCD. And let's take those screws out. Plastic stuck here onto another chip. That's a Mitsubishi M5093. On the second thought, I think the Mitsubishi chip is driving the LCD. Oh, I've made it show something by disconnecting it. It had a yellow backlight, and it is zebra strip. Oh, just static charge is making the LCD come on. All sorts of characters are coming up. It's not uncommon. It was one of those 16 segment displays. It's like a 7 segment but with just more lines in the middle. And then we've got a piece of frosted acrylic glued in place that was dispersing the light, and this little clear window, it was just a mask. Almost all the legs from this chip go to the top part of the LCD, and almost all pins of this chip, or about half of them, go through to vias and connect to the bottom side of the LCD. So that's unusual connection. So let's look at the guts of the phone itself. The front has got nothing here. Everything is covered by the cans. There's just the connector that was mating with the other PCB, and that's about it. We've got the proprietary connector for charging here, and an external antenna connector to be used whilst in a vehicle, presumably. And interestingly, we've got the air coil here right next to the antenna input. None of those pre-made inductors. Someone had to take a piece of wire and wound it up, probably on a drill bit. Over here we've got 5 trim pots and 3 more over here. So one of those stands says APC, now next one APC fine. The best acronym I could find for this APC was automatic phase control, which is basically a technique of tuning a frequency by comparing the phases of 2 signals. And we've got demo. Again, I have no idea what demo is for. RSSI, received signal strength indicator, presumably. So something to do with that, and mod, probably modulation, as this was analog circuitry, so that would be analog. And then we've got SAT, DTN and ST, more trim pots over here. Most of the stuff is covered by those copper plates. A ceramic EEPROM TMS 27C256-120JL in a socket. If someone was to wanted to mod a telephone, I think this is where they would plug in and modify what's inside this chip. Those were erasable by ultraviolet light, so you've got purposely covered up a window. Underneath here there is a quartz glass window that if you shine ultraviolet on this for long enough, it will erase the memory completely, and you can reprogram that again if you wish under the can. Oh wow, so this is interesting. So this is all sorts of filters in here, ceramic high frequency filters, which I have no idea how this stuff works. On top of this we've got piece of metal and with a few cutouts, and that's an antenna for something. So that's one piece of antenna equipment. This PCB is the second one, and then there was actual antenna here. It looks like they weren't concerned with the space inside of those. The whole body, by the way, is some sort of metal, but it's not magnesium as I initially thought. Is it magnetic? Slightly. It's ever so slightly magnetic. That's aluminium, and the back plate very slightly magnetic again. It's far too heavy for magnesium. Magnesium is really light. And here is a brass connector where the antenna actually screwed in, and that was screwed into here, and it was snaking through those tracks which have been shaped very specifically for their job role. So yeah, it's not about just making a connection, it has to be a connection of a specific shape. Switch that tells the phone that the antenna has been erected. Okay, here is a tiny coax connector that was plugging into the board, and that goes to antenna, and that's on the other side. So we've got 2 sets of PCBs sandwiched on both sides. Those filters are made by Gigafil. Look at this part number. Can you imagine making a phone call to your supplier and saying, do you happen to have in stock DFC7R933PO33BTP? Here we've got a TDK marked device. It's probably a filter, 872 to 950 MHz. And this metal thing, what on earth is this? Is there some sort of power section? Because that's where the battery connects to, and it goes onto this board. There's a piece of string. Why is there's two pieces of string? Why is there two pieces of string in a mobile phone? That's an old technology that should have never been forgotten. Is Apple using a string when they make an iPhone? No. Why? Because they're not good enough. Look, every board has got a oh, I know why. That's to take the board out. That's nice. Look, now I know I can take this one out properly. So that's for servicing. So if you were to take the board out of something, test it and repair it, because bear in mind those things cost thousands and thousands of pounds, so they were not a throwaway item like these days. If this was broken, it would get serviced and it would get repaired. So if they had to change a board in it, they would, because the board itself wasn't that much expensive. This thing as a device. So this is why the strings are here. You pull on it and it takes it out the right way. That's very nice. We've got a Sanyo battery for backup. We will have a closer look at this. And here we have, look at this, this is to connect this to the body of the phone so it made good electric contact. Murata D98 MOC512. Here is another one with a trim pot, 12.8 MHz, and another filter device. We'll take those apart later on. There is a Sony chip A1003B, and that's how it used to be sitting together inside. There we go. That is a really nice construction. Very serviceable, especially with those strings. This is wicked. Strings to pull out if you need to service something. I'm curious to see what's underneath this can or shield, and I think this whole thing is a heatsink, and inside there will be some power elements, because as I said, the power from the battery goes over onto this board, and over here we've got a series of electrolytic caps. So I think, ooh, a hybrid, Japan, FMC 08090216, some sort of hybrid module, which does come apart, but not in this state. So yes, I don't want to break anything just yet. I think that's it. So I've got it all taken apart. We'll have a really close look at every single board in here, just to see what it covers up. I need to look up those chips to see if I find any information on them. But as far as this video, that's as far as we can go on this occasion. Thank you very much for watching, and if you enjoyed it, please do like the video, share and subscribe if you haven't done that already. Stay tuned for the part 2. For the time being, take care.